Okay, so the warm-up from 4-1 kind of has most of what we talked about in this section, which was finding coterminal angles in both radians and degrees, finding the complement and the supplement in both radians and degrees, converting between radians and degrees, and then arc length was the last thing, okay, that SOAR formula. So if I'm trying to find a coterminal angle in degrees, what do I do? Good. I'm going to add or subtract 360, right? So if it starts as a positive 120, I want to add 360, and I get 480 degrees. That's my positive coterminal angle. And if I want to find my negative coterminal angle, what are you going to do? Subtract. Good. Subtract 360. So I'd get negative 140. If it's so small, like so far negative that even though you add 360, it's not negative. I mean, it's still negative, then we have to add again. And if it's so big that even though I subtract 360, it stays positive, I would just keep subtracting. What would you do if it was in radians? What do we add and subtract? What is it? 2 pi. Good. Okay. The equivalent of 360. All right. Number 2 says find the complement and the supplement. So if it's a complement, what do I do? Good. So complement means it adds to 90, right? Which would be 90 minus theta, or it would be pi over 2 if it's in radians, which is this case.
Wait, wouldn't the negative coterminal...
Brain not fully awake yet. That's a negative 240. Okay. All right, so complement, I'm going to subtract from 90 if it's in degrees. I'm going to subtract from pi over 2 if it's in radians, which is this case. So pi over 2 minus pi over 3. I got to give it a like denominator, which is 6. So 3 and 3 and 2 and 2. And I get 3 pi over 6 minus 2 pi over 6, which is pi over 6. So that's my complement. And then to find a supplement, you're going to subtract from what? 180 if it's in degrees, and if it's in radians? What's the equivalent of 180? Pi, good. So I would do pi minus pi over 3, 3 pi over 3 minus pi over 3, which is 2 pi over 3. Good so far? Okay. C, convert from the angle from radians, or from degrees to radians, or we could go the other direction. So if I'm going degrees to radians, I take theta and I multiply it times pi over 180. If I'm going radians to degrees, then I take theta and I multiply it times 180 over pi. So this one is in degrees. I'm going to multiply times pi over 180. I cancel out my zeros. I can divide both of those by 3. This would be 5 and 6. So I get 5 pi over 6. Questions on that one? Okay. And then last up in this section was the arc length. So to find arc length, we use the formula that is S equals theta times the radius. And what's special about theta? It has to be what? In radians. So when I look at number 4, it says a circle has a radius of 4. That's my R. Of 7. That's my R. And then it says find the length of the arc intercepted by the central angle of 210 degrees. So the first thing I got to do is convert that to radians. So cancel through the zeros. 3 goes into these again. And I get 7 pi over 6 would be theta in radians. And then I'm going to multiply that times 7. So 7 pi over 6 times 7 is 49 pi over 6. It actually gives you a unit of measurement. Like this would be in inches if it had asked for it. And these, like the quiz on Thursday, there'll be no calculator, so you'll leave them exact. Questions so far? All right, today, I know I'm a nerd that like teaches math for a living, but I love the unit circle. Today we're going to learn the unit circle. If you learned it last year, fantastic. This could be review. If you didn't learn it well last year, you're going to learn it this year. It's just something that's going to happen, okay? I'm going to teach you how to fill in the unit circle, and then I'm going to teach you how to use the unit circle, because we can use the unit circle to find trig values of angles. So we can use the unit circle to find sine, cosine, tangent of any circle, of any angle on that unit circle, or any coterminal to it, okay? So if memorization is your thing, and like you're not one of those types of people that likes to set up the right triangle, that's where the unit circle is great, okay? If you prefer to set up a special right triangle like 30, 60, 90, 45, 45, 90, that's in 4-3. I'll teach you how to do that too, and then you get to choose, okay? But we're gonna focus on the unit circle for today. So this is what a unit circle looks like, okay, filled in. This is a circle that has a radius of 1. So if I start at 0 in the middle and I go to the right, I went to the right one, so it's 1, 0. I go up 1, now it's 0, 1. I go left 1, it's negative 1, 0. I go down 1, and it's 0, negative 1. So those are your 4 quadrant angles. If you literally went out 1 unit in each direction, that's what it would look like. And then there are 3 parts to every special angle. The first is the degree measurement. There's a pattern to it. Okay, we're going to talk about it. It starts at 0 and it goes all the way back around. It actually finishes at 360. The top is 90. The left is 180. The bottom is 270. We talked about that last week. Okay, and then all the angles in between are in the pattern of 30, 50. Oh, wait, I did that in the wrong spot. 30 from 0 to the first one is I add 30 degrees. Then I add 15 degrees. Then I add 15 degrees. And then I add 30 degrees. So 30, 15, 15, 30 is the pattern all the way around your circle. So from 30, I would add 30 again. And then I would add 15. Then I would add 15. And then I would add 30 again. And I'd repeat it again. 30, 15, 15, 30. And the last one, 30, 15, 15, 30. So if you understand that pattern, you have just filled in 1/3 of your circle because it's all the angles. We're going to do this on a blank one in a second, okay? Then comes all the angles in radians. So 0 all the way around to 2 pi would be where this finishes in radians, okay? And there's also a pattern to those. So we talked about last week, pi over 2 would be at the top, pi would be on the left, 3 pi over 2 would be on the bottom, and 2 pi would double back all the way around. But in between those, there's 3 special angles in each quadrant. The one closest to your x-axis is your over 6 in each quadrant. The one closest to your y-axis is your over 3 in each quadrant. And the one in between is an over 4 in each quadrant. And then comes the numerators. They all have pi. In the first quadrant, it is just pi. In the second quadrant, it is 1 less than the denominator. So if my denominator is 3, then my numerator is 2. If my denominator is 4, my numerator is 3. And if my denominator is 6, my numerator is 5. So second quadrant is 1 less. Third quadrant is 1 more. So my numerator is 1 more than my denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3. And then in the last quadrant, it is 1 less than double the denominator. Or you can memorize 5, 7, 11. And then every single special angle has a special coordinate point next to it. Every over 6 has the coordinate point that is root 3 over 2 and 1/2. And this comes from a special right triangle, a 30, 60, 91, okay, which we'll talk about when we get to 4-3. The over 4 is the one in the middle, and that is root 2 over root 2 and root 2 over root 2. The over 4 is your 45 degrees, so hopefully that makes sense because if it's a 45, 45, 90 triangle, it's isosceles, so they would be the same. And then the last one is your over 3, and every over 3 is the reverse of your over 6. It'd be 1/2 and root 3 over 2. And then the only thing that changes are your signs when you go around your circle. In the first quadrant, they are both positive because your x and your y would both be positive. In the second quadrant, the x is negative, the y is positive. In the third quadrant, they are both negative. And in the fourth quadrant, the x is positive, the y is negative. Questions so far? Yeah.
What did you say the fourth quadrant was? It was like
1 less than double, or 5, 7, 11. If you can memorize 1. But it's 1 less than double because if you keep going, right, you hit 2 pi, and that is double. All right, do it from scratch. So if you already started to fill this in, okay, this should be a separate document, right? It's a separate PDF. I would say you're going to do this. You can duplicate this note as many times as you want until you know it, okay? Because, again, this is part of your quiz on Thursday. So I start with the angles and degrees, okay, because I think it's the most innate in most of you, okay? We start on the right with a 0. We go to the top to the 90. We go to the left, 180. The bottom, 270, and come back around 360. So 4 quadrant angles, but 5 angles because we come back to 360. What I say the pattern was from each angle in each quadrant. What do you add? First 30, right? 30, then 15, then 15, then 30. So if I go from 0 and I add 30, I get what? 30. Add 15 to that, 45. Add 15 to that, 60. Add 30 to that, 90. If you fill in your quadrants, it's like your checkpoint. Did I get to the right thing? What do I add to 90? 30, so that's 120. Then add 15, good, 135. Then add 15, good, 150. Add 30, and I hit the 180. Do it again in the third quadrant. 180 plus 30, good, plus 15. Good, plus 15. Good, plus 30. I'm at 270, which is in the bottom. And then fourth quadrant, add 30, 300, add 15, 315, add 15, 330, add 30, I'm at my 360. So 1/3 all the way down, okay? Questions so far? Okay, now we're going to do the angles in radians. So 0 degrees is the same as what radians? 0. 90 degrees is the same as what radians? Good, pi over 2. 180 is the same as? Pi. 270, 3 pi over 2. And 360 degrees, same as? 2 pi. What denominator goes closest to the x-axis? It's either 3, 4, or 6. Which one goes closest to the x? 6. Because think about it, it's the smallest angle, so you'd be doing 180 divided by 6, right? Instead of 180 divided by 3. So this is every single one of the ones closest to the x-axis gets an over 6. Over 6, over 6, over 6. The ones closest to the y-axis get a over 3. Good. Over 3, over 3, over 3, over 3. And then the in-between, over 4. With me so far? Okay. Every single one gets a pi, right? In the first quadrant, that's all it gets, just pi. In the second quadrant, what's true about the relationship between the numerator and the denominator? Good. 1 less than the denominator. So this is 2 pi over 3, 3 pi over 4, and 5 pi over 6. In the third quadrant, what's the relationship? 1 more. So 7 pi over 6, 5 pi over 4, 4 pi over 3. And in the fourth quadrant, 2 ways to remember it. One is 1 less than double, right? So if I double the 6, it's 12. 1 less than that is 11. 1 less than double would be 7. 1 less than double would be 5. Or we memorize 5, 7, 11. We still good? Okay, so now you're 2/3 the way done. Last thing we're going to do is all the angles. So what is every over 6? Good. Good. Root 3 over 2, 1/2. So I'm filling in every over 6 with that. Root 3 over 2, 1/2. Root 3 over 2, 1/2. and root 3 over 2, 1/2. Every over 3 is the reverse, right? So every over 3 gets 1/2. Root 3 over 2, 1/2. Root 3 over 2, 1/2. Root 3 over 2, and 1/2. Root 3 over 2. Root 2 over 2. And what would be the positive, negative signs in the first quadrant? Both positive. Second quadrant. Good. X would be negative. Y would be positive. So I'm going to put a negative on all the X values in that first quadrant. In the second quadrant. They're both positive in the first quadrant. Third quadrant, what's true about my signs? They're both negative. So negative, 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 negative. And in the fourth quadrant?
Y is negative.
Good. X is positive, Y is negative. And then the only thing that we haven't filled out is what actually forms this circle to begin with. And that is moving right, left, up, and down 1. So to the right 1 would make this 1, 0 on the right. Up 1, 0, 1, left 1, negative 1, 0, and down 1, 0, negative 1. Questions? How many of you are pretty confident in your unit circle skills, just out of curiosity? Okay. All right, good. Now let's. Tangent is 0 on the right and the left. It's undefined at the top and the bottom. And then every over 6, it's root 3 over 3 because it takes 2 3s to make a 6. Every over 4 is 1. And every over 3 is just root 3. So if you want to add on your tangents, even just like one quadrant, use it. So this is basically the explanation between the relation of your arc length and the unit circle, okay? If I took my circle and I had a radius of 1 and I drew a bunch of little right triangles inside my unit circle, they would be 30, 60, 90, 45, 45, 90 triangles. And in 30, 60, 90, and 45, 45, 90 triangles, your angles or your side lengths have a special ratio, okay? It's either 1, root 3, or 2, okay, if it's a 30, 60, 90 triangle, or it's root 2, and, or no, 1, 1, and root 2 if it's a 45, 45, 90 triangle. So each of those little coordinate points came from that. Now we get into the trig. So sine, cosine, tangent, cosecant, secant, and cotangent. These are the 6 trig functions you're going to have to find the values for. On the unit circle, so not in all the things that are sine and cosine related, but on the unit circle in which your radius is 1, then the sine is the y coordinate of that point. The cosine is the x coordinate of the point. The tangent is the y over the x. And then your reciprocal functions, we would flip cosine or flip sine to get cosecant. We would flip cosine to get secant, and we would flip cotangent, or we would flip tangent to get cotangent. So now go back to all those coordinate points. Every x value is a cosine, every y value is a sine, and every tangent is y over x. So here it says, use the figure at the right to find the trig functions at t. So this time I gave you the coordinate point. Eventually we're getting to the point where you have to know that based on the angle. So I'm going to do the cosine, well, I'll do sine. Sine of t, cosine of t, tan of t, cosecant of t, secant of t, and cotangent of t. Which part of the coordinate point is sine? The y. So this is root 3 over 2. Which part is cosine? X, which would be 1/2. How do I find tangent? Good. So it'd be square root of 3 over 2 over 1/2, which becomes square root of 3 over 2 times 2 over 1. And that's just root 3. And then we're going to flip them. So I'd get 2 over root 3, which can't get left that way because we have to rationalize it. This becomes 2 root 3 over 3. Flip the cosine to get the secant. That's just 2. Flip the tangent, and if it's root 3 over 1, this becomes 1 over root 3, which also gets rationalized to root 3 over 3. So every over 3 and every over 6 is going to have those 6 values. Sometimes they're switched, obviously, but those are all the same.
Root 3 times root 3 is just 3.
Yep. It'd be like root 9, right? Which would just be 3. Anytime you multiply a root by itself, it gets rid of the square root. Okay, so now take it a step further. Now it's going to give you the angle. So find the point xy on the unit circle that corresponds to the real number t. Now I'm giving you the angle. What's the denominator on this angle? Over 3. If you know your over 6s, over 4s, and over 3s, you already know this coordinate point. You just got to figure out where it is. So an over 3 has the coordinate point that's 1/2 and root 3 over 2. Now figure out where's 2 pi over 3. You can either look at your unit circle if you filled it out, right? Or what's the relationship between the 2 and the 3?
One less.
It's 1 less. Where does 1 less live? Second quadrant. And in the second quadrant, you'd have a negative x and a positive y. So now I know my coordinate points. So then sine root 3 over 2, cosine negative 1/2, tan root 3 over 2 times a negative 2, negative root 3. Cosecant, flip it, 2 over root 3, rationalize it. Secant, flip it. And cotangent, flip it, rationalize it. So you should be able to do this for every single over 3, over 6, over 4 on your, and over 2, really, on your unit circle. And then we're going to start to even say, okay, what happens when it's coterminal? What happens when that says 17 pi over 3? You'll be able to also figure that out. We good so far? Okay, so instead of having to y over x your entire life to get tangent, I'm going to add on the tangents to our coordinate points. Number 6, that has the coordinate point of root 3 over 2 and 1/2, has a tangent of root 3 over 3. Every over 4 that has the coordinate point root 2 over 2 and root 2 over 2 has a tan, that's 1. And every over 3, which coordinate point is 1/2 root 3 over 2, has the tan of root 3. If you memorize those, now you don't have to do y over x every time. So for me, how I memorize it is that it takes 2 3s to get a 6, but it only takes 1 3 to get a 3, okay? And then obviously if the x and y are the same, then the tan is 1. But if you just memorize those, now you don't have to y over x at all. We good? Yes? Yeah. Yeah. God bless you. All right, so now it says evaluate if possible just the sine, the cosine, and the tangent of the real number. Okay, so look at A. What's the denominator?
3.
Over 3. So if it's an over 3, what's my coordinate point? 1/2 root 3 over 2, right? And we just said where does 2 pi over 3 live? Second quadrant, so this is negative. So my sine, root 3 over 2, cosine, negative 1/2, and tan, now we know our over 3, right, is root 3, second quadrant. Each one has a different sign, so that tangent would be negative. Where is negative pi over 3? We talked about last week that there's 2 ways to do negatives, right? Either go clockwise, okay, or figure out where that angle is normally and fold it like a hamburger. So where does pi over 3 typically live? in the first quadrant. This would be pi over 3, right? So if I fold it like a hamburger, that's where it's negative. So now, same coordinate point because it's an over 3, but I'm in the fourth quadrant. What's true about your signs in the fourth quadrant? The x is positive, the y is negative. So my sine, negative root 3 over 2, cosine, 1/2, tan, it's an over 3, so it's root 3. It's in the fourth quadrant where one sign is positive and one sign is negative, so it's negative. All right, then you go to C, 6 pi over 3. And if you fall for it, it's at an over 3, so you would list the same coordinate point. But what's true about 6 pi over 3? It can be simplified. That's really what? 2 pi, right? 2 pi. What's the coordinate point of 2 pi? 1, 0. It's on the right. So sine, 0. Cosine, 1. Tan, y over x. So 0 divided by 1 is 0. Tangent, 0 on the right and the left, and undefined at the top and bottom. Still good? All right. So this basically just says that every single angle that's on that unit circle is cyclic, because if I keep adding or subtracting 2 pi or 360, those things repeat. So the domain of the sine function, the cosine function, is a set of all real numbers. There is nowhere on my circle where sine and cosine are undefined. The range of those functions is a set of all real numbers from -1 to 1, meaning it can never be smaller than -1 and can never be bigger than +1. It can include those two because we know if we go to the right, left, up, down, one of them is 1. But it can never be smaller than -1, can never be bigger than -1. If you think about what sine is, right, it's like opposite over hypotenuse. You're basically saying your opposite side is bigger than your hypotenuse, which can't happen because the hypotenuse has to be the biggest side. And they're periodic, which means that the functions have a repetitive or cyclic manner for every, and the period for each is 2 pi. So if we combine together what we did today with what we talked about last week. Last week we said every even whole number would be where? Do you remember? It starts at 0. It doubles back around to 2 pi, right? So if I keep adding 2 pi, what happens? What's next? 4 pi, then 6 pi, and so on and so forth. So every even whole number is on the right. And then every odd whole number is going to be on the left. So if I said, what's the sign at 22 pi? You should be able to give it to me because you know 22 is on the right-hand side. You know the coordinate point. What's the cosine at 27 pi? You should be able to give it to me, okay? Because you would know the odds are on the left-hand side. And then the vertical and the vertical axis is your your halfway point between your evens and odds. And the bottom is your halfway point between the odd and the even. So I could ask you to find literally like 31 pi over 3. And instead of subtracting 2 pi and 4 pi and 6 pi, what you can do is take this number and convert it to a mixed number. So what is 31 over 3 in mixed number form? 10 and 1/3 pi, right? Or 10 and pi over 3. Separate those into 2 parts, whole number and fractional part. What's the whole number? 10. Is that even or odd? Even. So I'm saying that 10 pi is actually over here on the right-hand side. So then I go to the second part of that number and I say, is that number in between 0 and 1/2? Or is it between 1/2 and 1? And what is that? It's in between 0 and 1/2. So this is at the over 3 in the first quadrant. And if you know your coordinate points, that is 1/2 root 3 over 2. And your tan is root 3. So you can do this with your unit circle angles if you know them well enough, obviously, on your circle to just like see them and know where they are. But you can also do that trick with every fractional number. So if I did 17 pi over 6, convert that to a mixed number, what is it? 2 and 5 pi over 6. The 2 tells you to start where? Even or odd? Even, so I'm on the right-hand side. 5, 6, is 5, 6 less than a half, or is it bigger than a half? Bigger than a half, so I'm at the over 6 in the second quadrant. My coordinate point is negative root 3 over 2, 1/2, and my tan is negative root 3 over 3. The more comfortable you get with those things, the faster you'll be able to pull these from your brain. Questions? All right, so see if you can figure these out. All right, so what's 13 pi over 6 in mixed number form?
2 times 6.
Good. Where does that live?
Even.
Good. I would go to the right, and then pi over 6 is less than a half, right? So I'm in the first quadrant. Coordinate point there, root 3 over 2, 1/2. So the sign would be 1/2. Good. And where's 5 pi? Odd, which is on the left, right? Coordinate point there is negative 1, 0. So the cosine would be what? Negative 1. Sorry. Good? Yeah.
What do you mean the sign would be negative?
Did I say sign?
Yeah.
No, cosine of b would be negative 1. Yeah, sorry. All right, last thing in this section are even and odd functions. So even and odd functions take on characteristics of, do I change the negative sign or do I not? Basically is the idea behind the even and odd functions. Trig functions, not like even and odd when we did our graphs, okay? So there are two trig functions that are even, and it is cosine and its reciprocal function, which would be secant, okay? And what these mean is that the negative value on my angle doesn't change the actual angle, the negative sign on my coordinate point. So if you think about if we were just to compare, let's do like negative pi over 6 and positive pi over 6. So if I'm at positive pi over 6 and negative pi over 6, the coordinate point is root 3 over 2 and 1/2. And here it's root 3 over 2 and negative 1/2. Okay? So just looking at this one pair of positive and negative angles, okay, which part of my coordinate point is my cosine? The x or the y?
X.
The x. What's true about the x values at both of these locations?
Positive.
They're both the same, okay? If I put them over here, if I did 5 pi over 6 and negative 5 pi over 6, they're going to both be negative, okay? So they don't change sign. So on cosine and its reciprocal function, because we would just flip it, secant, even if you change the sign on the angle, it doesn't change the sign on the trig function. So I remember that like the word even means even if I change it, it still doesn't change the trig function. So if I told you that the cosine of angle x was 1/2, you would tell me the cosine of negative x is also 1/2. It doesn't change it. That only works for cosine and secant. The other four, if I change the sign on the angle, it changes the sign on the trig function. So if I come back to the same example we're doing here, and I'm doing pi over 6 and negative pi over 6, which part of the coordinate point is my sign?
Y.
The y. What happens between 1/2 and negative 1/2? My sign changes, right? So if it's sine, S-I-N-E, then the sign, S-I-G-N, changes if I change it, okay? Same with tangent, and then there are reciprocal functions. So these you won't be given, like this wouldn't be given to you as a coordinate point. It might just give you the actual value. You got to figure out if you change it or not is the question. And we already know these. So like, I don't know if you remember from Algebra 2 Honors when we got into verifying trig identities, you got reciprocal identities, even and odd, Pythagorean identities, those kinds of things. We're going to kind of piece those together eventually. So here's just the even odd. So if it says use the value of the trig function to evaluate the indicated function. So look at A. Cosine of t is negative 1/3. And it wants the cosine of negative t. Do I change the sign on cosine? No. So cosine of t is the same thing as cosine of negative t, which means this is negative 1/3. And then what's the relationship between secant and cosine?
Reciprocal.
They're reciprocal functions. So if I want the secant of negative t, I could go back to the cosine of negative t and flip it. I'd get negative 3. I'm not changing its sign. Now go to sine. Do we change the sign if it's sine? Yes. So sine of negative t is 3/5 makes sine of positive t negative 3/5. And then cosecant, flip the sign, negative 5/3. All right, so it says use a calculator to evaluate the trig function and round your answer to 4 decimal places. First of all, this is the first time we have to pay attention to the mode on our calculator. As soon as you hit the button that says sine, cosine, or tangent, you have to be aware of what mode your calculator's in, because that's what's important with trig, okay? When we reset our calculators, it automatically puts it into radians, okay? So every time I tell you to second plus 712, it puts it into radians. If my question is in radians, then I obviously just keep it. If I needed to switch it to degrees, then I would switch it to degrees. How do I know if these are radians or degrees?
There's no degree symbol.
There has to be a degree symbol if it's in degrees, okay? It doesn't have to have pi to be radians, right? So all 4 of these are actually radians. So you're going to hit your mode button, and the 4th thing in the line is where it says radian and degree. We want to make sure we're in radians. And then to find secant, we don't have a secant button, right? But what is secant?
1 over sine.
Good. So 1 over cosine. So this would be 1 over cosine 4.5. So I literally just do 1 divided by cosine 4.5. And I get negative 4.7439.
Wait, this is not on
This is not on
the quiz?
the quiz. It will be on your test, but it's not on the quiz. Okay, cosecant is the reciprocal of what? Sine. So I do 1 over sine 0.9. And I get 1.2766. Then I go to tan, not a reciprocal button. I literally hit tan. But what happens when you do tan of pi divided by 2? What's your calculator tell you? Error, okay? Think about what's happening. At the top, where pi over 2 is, my coordinate point is 0, 1. What happens when I put the y over the x? It's undefined. Tangent's undefined at the top and the bottom, okay? So this is undefined, okay? I think on WebAssign it's the any.
Could that be on like non-calculator and you have to like
Yeah, everything that involves a unit circle angle could be on the non-calculator. Yeah. So I would even say I would go back to my unit circle and I'd add on the tangents for at least 1 quadrant. The 4 quadrants, and then 1 of the over 6 over 3 over 4. All right, and then cotangent would be 1 over tan, negative 1.2. Negative 0.3888. Questions? Okay.